Hello students, today we are going to discuss about fluid. Those substances which can flow from one place to another are called fluids. Fluids are all the liquids and all the gases. What is ideal fluid? Ideal fluid, the non-viscous, incompressible, irrotational, able to steady flow is called ideal fluid. Non-viscous, it means viscosity is zero. It means the friction between the layer to layer of the liquid is zero. Incompressible means we can't compress it. When we applied the force, there is no change in density of the liquid. Then this type of liquid is called incompressible. And irrotational, if we rotate any wheel inside the liquid, then it is not moving, it is not rotating in the liquid, then it is called irrotational. And steady flow means all the particles which are going ahead or which are going after the particles, then they follow the path of the particles which are ahead. It means steady flow means कह सकते हैं इसमें कि जो आगे जो पार्टिकल्स जा रहे हैं उनका पाथ फॉलो करने वाले पीछे पार्टिकल्स जो होते हैं, इट मीन्स सॉरी, जो भी पार्टिकल्स पीछे आ रहे होते हैं वो अपने आगे वाले पार्टिकल के पाथ को फॉलो करता है। तो इस टाइप के जो फ्लो को अपन बोलते हैं स्टेडी फ्लो। जैसे हम बोलते हैं कि मोशन ऑफ आर्मी ट्रूप जो चलते हैं उसमें जो पर्सन पीछे आ रहे होते हैं वो आगे चलने वाले पर्सन के पाथ को पूरी तरह से फॉलो करते हैं। दिस टाइप ऑफ फ्लो इज कॉल्ड स्टेडी फ्लो। नाउ द टर्म्स आइडियल फ्लो की जो टर्म्स है उसको अपन यहाँ पे एक्सप्लेन करेंगे। जितनी भी टर्म्स हमने ली हैं इसमें टर्म्स related to ideal flow. First is steady flow. What is steady flow? The fluid velocity at each point does not change with time, either in magnitude or direction. Velocity of all the particles remain the same at each point, but may be different at different points. For example, in above flow, this is a point A and this is point B. Then velocity of all the particles which are passes from the point A remains the same at that, same as it may be Va, same as velocity of all the particles which are passes from B remain the same at B only, it may be Vb. Means V and Vb are different, but all the particles, velocity of all the particles which are passes from B, the velocity at B remains the same. Similarly, velocity at A remains the same. So at each and every point, velocity remains the same, but it may be different at different points. Va is not equal to Second, incompressible fluid. What mean by incompressible? The density of the fluid remains constant during its flow. Density of fluid remains constant during its flow. Or we can say when we apply some pressure or force on the liquid, its density remains the same. Third point is non-viscosity. If internal friction between the layers is zero, then liquid is called non-viscous. Irrotational. Fourth is, it means there is no angular momentum of the fluid about any point. There is angular momentum of the fluid about any point. A very small wheel placed at any point inside such a fluid does not rotate about its center of mass. If we place any small fan or wheel inside the fluid, it does not rotate about its center of mass. The variation of pressure with height. We know that this is depth is h1, depth of lower part is h2, and height of cylinder is h only. Area of cross section of this cylinder is a. The upward force F2 will be P2 into A, and pressure will be equal to density of liquid rho g H2 into A. The downward force, it is upward force. The downward force F1 will be rho g H1 into A. It is downward at the top of the cylinder, and F2 is upward because here H2 is greater than H1, so that it implies F2 is greater than F1. Then resultant force F2 minus F1 will be equal to rho g H2A minus rho g H1A, that is equal to rho g H2 minus H1A is equal to rho g H into A. Here depth and area of cross section will be equal to the volume. Rho g V is the resultant force. From this is third one. This is the upward force, and it is also written as rho g H A, and upward pressure P equal to F by A, that is rho g H A upon A, that is rho g H. So pressure will be equal to rho g. We can write it into the differentiation form dP by dH, because pressure varies with respect to the depth, is equal to rho g, and dP is called in differentiation form dP will be equal to rho g dH, and summation of dP is equal to rho g summation of dH, so that P is equal to rho g H. Again, if atmospheric pressure is P0 is atmospheric pressure, so the total pressure PT will be equal to PT or P, total pressure P is equal to P0 plus rho g H.